Thomas, thanks for having me. Thank you all for joining. This is really a pivotal time for AI in education. And well, what a time to be an educator and a learner of languages. AI is a great opportunity. We've heard yesterday from Ken the wealth, about the wealth of opportunities as well as risks that AI brings. And today, I wanted to follow the path that Ken outlined yesterday and help you get a better intuitive understanding of what AI really is, specifically generative AI, so that you can better appreciate the opportunities and the risks. And then in the following sessions throughout the week, you will see, you'll get more practical tips on how to actually start implementing these types of tools in your everyday lives. So just to start with a show of hands, virtually, who here has already used generative AI systems or tools, either in their personal lives or in their professional lives? And by generative AI systems, I mean either ChatGPT or Microsoft Copilot or Google's Gemini, and so on. Okay, so we've got quite a lot of people who have already tried it. And please share in the chat, in the comments, what your experiences were and what your general impressions were. When I asked my students this question, I was surprised how low the yes percentages were. They used to oscillate around to 55%. So you as educators are definitely ahead of the game here. And most of what we think about AI, generative AI, are really large language models, or LLMs. And this is something that we will focus on today. So again, GPT, Gemini, these are examples of large language models. And I wanted to ask you how confident you are about your understanding of large language models. And we see that most people would say that they're somewhat confident. And so I think what we could start with then is maybe just a level set and for us to get a better understanding of how these models work. And then I hope that towards the end of the session, we will see more green answers and fewer red answers. So let's talk about understanding generative AI. Before we do that, we'll have to take a step back, take a trip down the memory lane and talk about AI in general. If you think about AI in education, when do you think the very first AI systems were built and successfully applied for education? You can use the slider, you can pick a date, and okay. So AI as a field started right after World War II, which is maybe why we have so many people picking that date. Actually, so the very first systems were successfully implemented around the early 60s, late 60s, and then into the 70s. Most of them were still prototypes, really. They were experiments ran in academias, especially in the US. The very first type of AI systems from the 60s and 70s and 80s, what we could call wave one, the first wave of AI systems, these were rule-based systems. The type of interface you see in ChatGPT, those types of interfaces were available before. It's not trivial, but it's possible to develop a system that will parse human language and text. But then the question is, how do we account for the reasoning of that system? And for many, many decades, people would build such systems using human-created rules. So this is a screenshot from an actual working system that was built to assist doctors in identifying bacteria-caused infections, and it was also used for treating doctors. It was also for educating young doctors. And this is an example transcript. So the text in bold is what the student wrote, and the rest of the text is what the system wrote. And the system, while evaluating the student's response, as to which particular bacteria may have caused the illness, relies on particular rules and refers to those rules. And you can see an example of such a rule. It's a if this, then that kind of a rule. And these systems worked surprisingly well. The main bottleneck was that people needed to come up with hundreds of rules. And this is why we haven't seen much success with those types of systems. They're also quite brittle in terms of not really being able to account for edge cases where the rule was not clear-cut. Then in the late 1990s, the second wave of AI came, and these were machine learning systems. So you may have heard that particular term, machine learning. And the idea here was that if we collect enough data, and if we tell the machine what that data is about and how to interpret that data, then we no longer will have to create rules by hand, and the system will be able to learn from the data. A good example of that system is actually a suite of Pearson products for summative assessment. Here's an example product called the Pearson Test of English. And successfully, since the Pearson pioneered the development of this type of fully computer-based assessment back in the late 1990s. And the main idea here was that if let's say you give to your students an essay on a particular topic, and many of you, just like me, have sort of hand scored those essays, maybe you annotated bits that you liked and bits that you didn't like. If you do that enough times for a particular essay, if you annotate it consistently, if you score it consistently across clear-cut rubrics, then you can actually feed that data into a machine learning model, and that model will learn how to mimic your scoring patterns, so your domain expertise. And this infographic here shows the example for speech. So I just described the essay, the text assessment, and then for speech, what happens is we collect real-life data on how students respond to activities. We transcribe that speech. We have trained professionals rate speech across very rigorously developed rubrics for content, pronunciation, and so on. And then we use machine learning methods to train an AI model, which is able to predict human ratings, so it's able to score or rate people's learners' speech just like a human would. And then we rigorously validate those models, so that we can be sure that the machine scores the learner's response just like a human would. In fact, the machine is sort of more often in agreement with a human than two humans are with each other. And the era in which we are now with generative AI, that we could call that wave 3 of AI systems. And that actually started a couple of years ago. The main idea here is that we still use data, but we don't really care that much about annotating the data. We just want to gather as much data as possible. In this case, when it comes to LLMs, we'll gather text data, so Wikipedia, all sorts of books, maybe internet forums, and then we'll put it into a neural network, which is a type of a machine learning algorithm. It's an AI algorithm. And that neural network will try and learn without human expertise, without us really telling the machine how it should learn. We will still, in the case of text generation model, tell the system what its goal is. So in the case of text generation system, the goal is to predict the next word in the sentence. And Ken, yesterday, you made a very good point about that these kinds of systems are kind of like autocomplete on your phone. They just try to predict what the next statistically probable word is. And what I'm showing to you on the screen is a classic example where a well-known AI researcher took Tolstoy's War and Peace and put it into a neural network 100 times, then 500 times, and up to 2,000 times. And you can see at each stage how the neural network learned how to, without any supervision, just by trying to predict the next character, how it started to put words together, sentences together, and then actually, eventually, coherent language. it could just generate language in the style of this particular book, but still it could do it surprisingly well. So LLMs learn exactly in this way. They learn without human supervision. We, by chance, hope that they by chance, by reading all the possible data sources, these vast data sets, will learn how to imitate not only language, but also the types of tasks that humans conduct in language. So translation, summarization. If translation is mentioned in many places in the text data set that was used to train the AI, then the model will know what it means when the human asks for a translation. But this only gives us a model which is good at generating text, but doesn't really have the guardrails. It's not really aligned to our expectations of good behavior. So it could produce toxic output, it could produce misleading output, and so on. So usually the next stage of developing systems such as ChatGPT or Gemini and so on is supervised alignment. So this is where we go through from a large language model to an assistant-like system such as ChatGPT. And there are a couple of ways to do it. I'm showing you two examples on the screen. Again, just so that you develop an intuition as to how exactly these models are developed. Once you have a system that can generate language, the next step is for you to actually give it examples of what it means to give good advice or unsafe advice. So in this particular example, you can see two action examples proposed by researchers. In one case, the model is instructed. Again, this is something that a human wrote to give an example to the model as to how it should respond when someone asks for dating advice. And this is an example of how the model should not respond when someone asks about how to silence the neighbor's barking dog. And another example is if you ever clicked on the thumbs up, thumbs down icon in some of those LLM-based systems, such as ChatGPT, then you yourself provided this reinforcement to the system as to whether it provides you with a good response or a bad response, which will be used to further fine-tune that model and align it to the expectations of the general population as to how such models should behave. So I wanted to drive this one message home and show you really how these types of models work. Because Ken yesterday mentioned that they are not intelligent, which it's interesting. It's an interesting question and an interesting thought experiment to think to what extent they are different from humans and how they quote unquote think. So I asked one of the LLMs to generate an invite for this very session, and this is what it produced. We are less interested in the text and more interested in what's behind the scenes. What you see under the hood here are the words that the model thought were more probable in this context, more statistically likely to appear. So the model actually thought we should have started with "dear educators," but it used this particular word, teachers. And then in the next for this next word, are you looking? It also considered interested. So are you interested in, maybe in learning? And then for this example here, classrooms. So are you looking for ways to incorporate AI into your classroom, lessons, teaching, curriculum? So these are all the other options that the model considered, but actually it settled on this one. So you can see that in many cases, the very choice of the word is it a preposition, is it an adjective, is it a noun, guides the direction in which the model goes with its output. So the model thinks, quote unquote, word by word. So it doesn't really have the capacity to plan its response in advance. But if you give it enough time to think, then it may produce pretty good behavior. Okay, so let's jump onto how to think about AI systems in education. Now that you know the basics and you have this intuitive understanding, what do you think the impact will be of generative AI systems on language education over, let's say, the next 5 years? Let's keep it realistic. Okay, so we have no one saying it'll be insignificant. And when I ask this question quite often to various audiences of educators, as well as institutional leaders, this is usually the response that I get, which is mostly significant. And I think that the biggest opportunity we have in education, this is something that Ken mentioned, and what other speakers this week, Magda, Billy, Ilya will mention as well, and they will actually show you practical examples of this, is content personalization. I'm showing you on the screen 2 examples from Pearson, not from language learning, but from other disciplines where we have already deployed LLM-based systems successfully. On the left, you see an example of just-in-time tutoring. So imagine it's 2 a.m. in the morning. Someone is studying for a test. In this case, it's chemistry, and they are really stuck on a particular problem, and they don't have the teacher's not available at 2 a.m. And the best thing they have right now is this AI-based tutor, which can guide them to a better understanding. So I'm giving the final answer. That's not the point. The point is still for the learner to learn, not just to complete homework. But in this case, it'll be able to actually guide it step by step and provide personalized, just-in-time feedback. And the other example is the ability for those types of systems to generate questions and provide them on the fly when the learner needs them, when the learner wants to practice more, they have an upcoming test or an exam, and they just feel they've had a good understanding, but they would like just more practice just to be more reassured. That's also a very good immediate application of large language models. So personalization of content, in the case of Pearson, this actually plays out really well with our products because we have quality content which learners use anyway as a reference source. But then LLMs and those types of AI systems allow us to start offering this just-in-time personalized help to them. One thing that you may have heard about, maybe you've seen examples of that on social media, is people trying to use those types of tools for assessment. So they would take an essay, put it into an LLM, such as ChatGPT online, and they would ask it to grade it. I encourage all sorts of experiments with AI in principle, but then I would like to echo Ken's point from yesterday, that you should approach such experiments with caution. The main challenge we as a humanity have with LLMs is that we don't know really how they work, and we cannot guarantee that their output will be 100% reliable. So I encourage you to try this now or later at home. Take an essay, any essay, write it on your own, and take it from the web. Maybe ask a system to write it for you, and then put it into the AI system and ask it to grade it. Then reload the page and ask it to grade it again. You can maybe come up with some scoring rubrics, and then you will see that each time when you rerun the system, you'll get a slightly different score, slightly different feedback. And again, for some types of use cases, this may be okay, but for higher stakes summative assessment cases where it's really the learner's grade that's at stake, I would personally advise against using these systems right now without any adaptation. And another interesting thing is that the behavior of those systems actually changes over time. There have been studies already showing how the behavior of some of the commercial AI systems changed last year, in some cases for the better, in other cases for the worse. For example, systems that could do math reasonably well suddenly lost that ability as they accumulated more data and possibly were fine-tuned to fix some things, but actually other things broke. It's actually quite difficult, even for us as AI developers, to fine-tune, to adjust the behavior of an LLM in a way which is reliable and robust. This is still a very nascent field, and everyone is still learning really how these systems work and poking at them and analyzing the output to ensure that we can deliver assessments that are valid, fair, and reliable. This means, however, you can use LLMs for formative assessment, so for feedback. In those cases, they actually perform really, really well. In our case, LLMs allow us to decrease the time and cost of building systems which don't have to be super rigorous, but still will be helpful if they provide not a score, not a grade maybe, but feedback for improvement. So what you see on the screen, for example, is a feature we just added to Monday by Pearson, one of our formative assessment and practice products, where, and I'm going to show you that in a second, we developed a chatbot which allows learners to practice actual real-life scenarios in a manner that was not possible up until now, without spending years and millions of dollars in development. So these types of systems, these LLMs, are good enough for, when adapted correctly, for these types of systems. And then when they are powered with authoritative content that we provide, or our other types of more predictable machine learning models along the lines of what I showed you before, where we actually control how the model is developed, we control the data and so on, then this allows us to offer a really nicely packaged interactive learning experiences where we focus on the active learning rather than just like passive, highlighting of the textbook. We go into this construction of reading, this active practice and interactive learning, where you sometimes have to even argue maybe or at least challenge the tutor. Another thing that these types of systems allow us to do is focus on what we call future skills. I'm including here a link to a recent Pearson report focusing on the top 10 skills needing most improvements to meet the demands of various countries' economies in the near future. And these are, unsurprisingly, not really hard skills. These are soft skills. So these are the types of skills that we can and should help learners acquire through language practice. So, and they also are great for pairing with these types of interactive, scenario-based formative assessment and practice experiences. And what I'm going to show you now, I'm just showing you this screenshot just for the sake of brevity. I won't show you the entire exchange. Wanted to show you that example of Luna, the AI-based tutor that's available in Monday by Pearson. The breakthrough here is that you no longer have to stick to a very particular script. We are showing you some options. In my case, I'm Polish and I wanted to learn English, so I asked for a session for Luna to help me learn English. And one of the example scenarios, making an appointment. And once the conversation starts, it's pretty much up to you how you want to respond. There are some suggestions. As you can see here in the middle screen, for example, one of the suggestions is, for my daughter, for my partner, in response to who is the appointment for. But you can speak using your own words. And obviously, this is a scaffolded scenario, so you won't be able to completely change the topic and order pizza. But if you stick to the scenario, the particular learning outcomes that this scenario enables, then you will be able to start practicing using your own words. And that's exactly the type of more active learning that LLMs enable. Magda Kania tomorrow is going to demonstrate to you similar learning experiences that are now available in our coursework products for classroom and for homework use. I'm not going to steal Magda's thunder. I wanted to invite you for the session tomorrow. And the main thing that I wanted to convey here, and I think you maybe got this idea right now, at Pearson, we're not trying to embed AI in our products just for the sake of doing it. We're not trying to solve learning as a technical problem, which it isn't. We're treating it as an educational problem. We're thinking about the learning design principles about the evidence as to how people learn and what works. And I'm showing you on the screen just some of the principles. If you look up online, Pearson Learning Design Principles, these are the white papers you will see. I'm just showing you a couple of pages from a couple of those white papers. This one focuses on authentic learning, this one on active learning and memory and practice, this one on self-regulated learning and metacognition, and this one about personalized learning and adaptive systems. And I also encourage you as educators to continue upskilling yourselves when it comes to AI, just like you're doing now, but also to rediscover those learning design principles, because now, finally, after all those years of waiting, you can start using AI to create your own interactive experiences. The only thing you need to know to program an AI system right now is not Python or Java or any other computer programming language. It's your own language, your natural language, English, Polish in my case. So the world is your oyster right now when it comes to how you would like to start bridging this gap that Ken mentioned yesterday from the current somewhat outdated education system towards what education could really be. But in order to do that, we need to ground our experimentations with AI and our applications of AI in these learning design principles. So I really hotly encourage you to have a read. These are really short, sharp and sweet white papers. Another thing that I think we should do, this is, for example, what I'm doing with my students. Even though I teach AI at a local university here, I still try to encourage my students to use AI. AI is becoming a 21st century job skill. It is just like with computer literacy and literacy and numeracy, AI literacy is going to be a required skill for the job economy. AI is being now embedded in everyday tools, in Microsoft Office, in Windows, in all sorts of productivity suites like that. So the best thing we can do right now for our students, apart from embracing AI and using it to help them learn better and faster, is actually also to help them understand how to use those tools. What are the opportunities? What are the risks? How they work? I'm including a quote here from a recent article where one of my colleagues and co-authors coined this term first draft automation, which I think really nicely summarizes the direction in which we're going with AI. So knowledge workers, for white-collar jobs, knowledge workers will no longer require to write a report from scratch. They will ask an AI system to do that for them, and then they will edit that draft. Same goes for press releases or job descriptions or all sorts of deliverables. So this is still early days. It's not like we're seeing this happening everywhere, but this is happening, and you will see it sooner than later. And both for our jobs as teachers or for our students, our learners, we should help them embrace AI and encourage them to use it. Okay, so I've showed you a couple of examples of generative AI. Where do you think generative AI will have the biggest impact on education? Okay, and in the meantime, I'll review the Q&A. Perfect. Okay, so we've got classroom content creation, lesson plans and activities as number 1, and dialogue-based tutoring and role-playing, number 2. school admin efficiency. I think that's an opportunity that many don't appreciate yet. I think that will be a tremendous time and cost saver. Okay. Yeah, and personalized learning experience as well. Thanks, Tiana. Yeah, I would probably personally, I would say what you chose as number one. I think that will be the most immediate impact. The most meaningful impact, I would say, will be number two, which is that sort of one-on-one dialogue-based tutoring. So, it won't replace, obviously, the educator. There's no doubt about that. But that will be an extension of the educator. You, as educators, will probably pretty soon will be able to program your own avatars in the sense that you were able to deploy them in the classroom for them to help your learners with their homework, score some assessments, and give you the information back as to what the overall profile of the class is, who struggles with what to focus on in the next class. And then obviously for the next class, you will generate some content using an AI system. Okay, so I will start addressing the questions in the Q&A soon. I'll just go through the slide because I think some of my slides will actually answer some of your questions. So when it comes to ensuring safe and secure usage of AI, it's on us as educators to ensure we review the terms and conditions of the applications we ask our students to use. In the case of Luna and Monty by Pearson that I just showed you, this is a proprietary system, and your learners' responses are not being sent elsewhere to an external third-party system, which, again, that may be used by that third party to improve their systems and use that data elsewhere. In our case, that stays within Pearson, because one thing we care about really is data privacy. And when it comes to use and misuse of the freely available democratized AI tools, such as ChatGPT or other LLM-based tools, again, it's on us to clarify the best practices for use in the classroom, clarify the expectations. If your school doesn't yet have guidelines for AI use, help create that. If you are noticing signs of misuse, address that. Some of the signs you may see is, well, if you play, I encourage you to play around with LLM-based tools, and ask an AI to provide a response to your homework. Maybe it's an essay prompt, maybe it's some other type of assignment, and you will see after a couple of responses that there's a particular style with which these types of systems respond. So you will be able to spot whether someone copies response one by one. Obviously, if learners start using other systems then to change that, or if they change that manually, the possibility of detecting AI-generated content decreases significantly. There are some systems right now which actually work really, really well, but they are, for now, specializing in very particular domains. So then I'm showing to you on the screen an example system which is built to detect when chemists write journal articles, and when they use ChatGPT, there are systems right now which work quite well for that. But that's because they've been fine-tuned, they've been sort of adjusted to really, really look at those types of texts. So I would caution against trying to play that cat and mouse game when it comes to trying to detect AI writing. That's not the point. The point is you have close relationships with your learners. So you will know who is more active, who is less passive, who aced all the previous tests or submitted excellent homework assignments versus who only now started to submit activities, who if you devote some classroom time for discussing the homework, like who can actually speak about the homework and displays the knowledge of that topic or can demonstrate some skills, we will have to move beyond just looking at the homework and look at this more holistically and try to assess the students' knowledge, skills, and attributes more holistically, and then look out for signs of misuse, and then be upfront about it, be clear about what's allowed and what is not allowed. But again, in general, and I'm trying to address your question here. In general, make it very clear: plagiarism, not okay. But on the other hand, pen and paper, unless really, really needed, also not okay these days. So we will need to move towards AI-enabled writing at some point. It's not that we should not teach writing anymore. I taught writing as well for a couple of years, and I appreciate the value of learning the rules first of how to write an essay, so that then you know how to break them if you want to write more creatively. But then again, if we want to prepare our learners eventually for the job economy or empower them with skills that will allow them to transfer between various types of jobs as jobs evolve in the AI-powered economy, then we need to embed this new type of writing and working with AI tools into our pedagogical processes. One example that I can show you is this paper by Mollick and Mollick, which I think is one of the excellent papers that have been written last year on the topic. It gives a couple of ideas as to how to structure prompts following learning design principles, and then how you can hand those prompts over to your learners so that they can put them into LLM-based systems, so that those systems play the role of the tutor, of a mentor, of a coach, of a fellow student, and you can tailor those prompts to match your level or your particular domain or topic of the class. I encourage you to experiment with that type of approach. Instead of asking students to write something, actually ask them maybe to give them a couple of questions and this prompt, and then ask them to work with an AI system that's enabled by this prompt, that's essentially programmed by you using this prompt to complete that activity. And you will see that students will appreciate this variety, and they will actually probably come back to you with quite a lot of feedback on how that experience went. I know my students did. We just finalized a pilot study, which will be published soon, where we experimented heavily with those types of AI-enabled activities. And they really, if you try and tailor them to your exact use, they can really engage students with the learning, even if that sometimes means that the students spot that the AI is wrong, but they were able to correct it. And that actually really makes some students quite happy. One other thing I wanted to make sure you're aware of is the inherent bias. Ken mentioned that. I'm sure others will mention as well. I'm showing to you an example here, of that system where you kind of we see what the most probable words were that the model considered. I prompted the model just with this: I study computer science at university, just like my ... And it was the model's job to fill out, complete the rest. And as you can see, the model, because it just quote unquote thinks in statistical probabilities based on what it saw in the training data, the model would like to really, really use the word brother or father in this context, or parents. So the word sister in the context of studying computer science at university is not really the top word. And that may perpetuate some of the social cultural biases. In fact, if you look at some of the large language models released 4 years ago, so GPT-3 was released in 2020, and some of the newer large language models, this is a good example from last year, on average, these models actually didn't get better in terms of reducing bias when it comes to gender, religion, race and color, and so on. A lower score is better. So you can see that this score is just slightly lower than from a model from 3 years ago. Another type of bias, we haven't really mentioned here image generation models. I know others will, but this is an example that has been circulating on the web for a couple of months now. When you ask a particular image generation model what a given professor looks like, and you get these responses, where again, it's on the one hand, it's obviously biased because that's what the data was trained on. But this reflects the data that the model was trained on. On the other hand, it's a good question as like to what extent we as teachers should like modify this. Should like because if you start now, really modifying the gender of every particular type of a professor, then you on your own may actually perpetuate your own biases. So maybe the best thing is just to have a selection of genders for each, and maybe that will solve the problem. One other thing I wanted to make clear is we are conscious that generative AI will not, as it removes some barriers to education, actually creates other barriers. One example is, as you've seen with the examples I gave you today, all those AI systems require devices, mobile devices, computers. They require electricity. They require Wi-Fi, frequent internet access. What you see here is the degree of the bandwidth of internet connection worldwide in certain countries. So you can see where that there was many areas of the world where internet access is not a given. And as we think about expanding access to education with AI, that's another thing we should keep in mind. Ken mentioned it yesterday, and some other people I know will mention it later this week in the webinars. One thing that we should really strive for is, as we help more people learn, that we should not build more barriers for learning. Finally, we will see where the future of generative AI goes. You may have heard in the media a lot of questions and comments about lawsuits. The main challenge is that most of the models very likely were trained on copyrighted data. It's an interesting problem. It's not clear-cut. If you look at examples such as Google Books, Google actually won a lawsuit in the Supreme Court where it was deemed that taking a copyrighted book and using it to create a searchable database, such as Google Books, constitutes fair use. So that's actually an allowed use case where you can take something which is copyrighted. And this is the same defense that is being used right now when it comes to those large language models and other types of generative AI systems. We'll see which way it goes. On the one hand, nothing may change. On the other hand, we may get back to pre-generative AI times really soon. Another thing you should be aware of, especially as you as educators, is that there's a tidal wave of upcoming regulations around the world. When it comes to the EU, for example, the EU AI Act, which has just been finalized in its final form, it proposed a risk-based safety framework where certain uses of AI, regardless of which type of AI is it like that more classical rule-based or machine learning or like generative AI, they are less or more allowed depending on the domain in which they are used. So education is a high-risk use of AI. So people who use AI, especially companies that who want to use AI, especially generative AI, that's the more complex and unpredictable AI, which is able to make decisions on its own, those entities will need to ensure that there's a proper governance framework for training those models, for management of data, so that companies don't use copyrighted data to train their models, ensuring a proper risk management process, and making sure that the human can always talk to a human and not just to the AI. These are all the things that will help us ensure that new implementations of AI systems are secure, especially when it comes to learners, especially when it comes to children. So right now, if you think about all these risks and barriers, this sort of more pessimistic side that I just described, which one do you think will be most critical when it comes to language education? Will it be the tech access, those types of first-order barriers, regulation, or the issue of data privacy and how we approach that? Or is it maybe the algorithmic bias built into the models? Or is it our ability to actually integrate those systems into curricula, which, as we know, doesn't happen quickly, may require a couple of years? Okay, so it's device privacy, it's number one. Data privacy, and then device and internet and electricity as number two. And curriculum integration. Well, at least I'm quite hopeful that you think curriculum integration will not be a challenge, because data privacy, at least at Pearson, we can account for and we can solve. Okay, and I wanted to ask you this question. I asked you this question at the beginning, but I promised that we will measure you again. So right now, after the session, when it comes to especially LLMs, but maybe also generative as well, like, how do you feel? Do you feel more confident now? Like, do you of how these systems work, of what the risks and opportunities are? Okay, so we are getting significantly more greens. We had 20% before, and significantly fewer no's. So that's great. Okay. And my final question to you is, before I go into Q&A, we've covered a lot today, and you will hear more throughout the week. But then, like, after these webinars, what is the one action you can take tomorrow, or maybe on Monday next week, to actually start implementing generative AI in your work? What is the one thing you could do? You can put responses here, or you could put them in the webinar chat. Okay, project planning. Exactly, start using it and start really getting that stuff, understanding of what it can do, what is it good at, what is it bad at, and so on. Role playing is an excellent example. Perfect. Many of my students use it in our own classes for writing. Perfect. Lesson plans, definitely, like all sorts of planning. I see a lot of that, all sorts of planning. That's exactly something that's an immediate application of AI. And then icebreakers, I got to say, I use that a lot as well for my young classes. There's only so much I can think of, and AI is at least it's great at generating ideas. Not all of those ideas will be great, but we as humans then will be able to select the best ideas. Dialogue. Exactly. Some of the use cases you're describing are also more advanced, where these are really things that companies such as Pearson will start providing once we embed those types of models in our products, so that they are grounded in quality, author-derived material, and scaffolded appropriately and designed according to design principles. And then we will embed those types of assessment systems that provide people with feedback on listening and encourage this sort of self-regulated learning. Okay, perfect. Thank you so much for your input. I will now go into Q&A, and I will address the questions So I think I've addressed some of them already. When it comes to how data is used, plagiarism instruction. Oh, Jamie, courseware you will see tomorrow will have a speaker, Magda Kania, who will demonstrate and show some good practices for using those types of more rope and response scenario-based activities that are available in our courseware. Okay, initiating an institution-wide response to AI. There have been some responses, and there's some good reports driven either by regulatory bodies. So in the UK, for example, the JCQ, so the Joint Council for Qualifications, issued a very good set of recommendations as to what to do and what not to do when it comes to the use of AI in assessments in the UK. In the US, on the other hand, the Department of Education released an excellent white paper, but maybe we can link later after the session, outlining what the ideal state and what the intermediate steps should be for implementing AI in institutions. I think we already have a lot of that. And I think the next question is I would encourage you to think about what is it that you can do within your own institution, and how you can take some of those best practices and start implementing them. Okay, so where is a good place to start trying AI in English language learning classroom? And what would be a good activity? Oh, perfect. So Matthew, we will have 2 other very practical sessions, one on Thursday and one on Friday. Thursday is Billy, Friday is Ilya, where they will give you a lot of examples of like how to actually start with the more practical approach. So I just wanted to start with this stuff, general purpose, entry-level introduction to how to really think about those systems, so that you can now see through the hype and appreciate that it's not magic. It's just like systems that can be built and work. And then tomorrow we'll talk about English courseware. Magda will do that. Thursday, Billy, and then Friday, Ilya will give you more practical examples using other off-the-shelf tools. Okay, and Susan, you asked a good question about like, how is a conversation chatbot different from what we have in something like ChatGPT-4. Those typical conversational chatbots that many of you may know from prior years, especially from customer support, maybe some sort of language education, those were really relied on dialogue. So scripted scenarios. You would have imagine like a tree, like a branch tree of all the possible options where this scenario could go, and that was quite constrained, really. And the general purpose AI systems, all the LLMs such as ChatGPT or GPT, they don't have any of those branching scenarios programmed into them unless you provide them. So this is really, the fact that they've been trained on a whole sort of data with very little guardrails that allows them to speak on any topic, which is also a double-edged sword, because they may confidently speak about things that they have no idea about, and they can also produce toxic or biased output. Okay, and okay, I'll take one more, then I'll hand it over to Thomas. Yeah, so Lindsay, reducing bias in AI is tough, because it's only a handful of companies, the biggest tech companies that produce those types of models for the most part. So it's on them to stop minimizing the inherent bias in those types of tools. Companies that use those tools to develop products, such as Pearson, there's a limited things we can do to provide guardrails, maybe to adjust those models further. And for the most part, we're happy with the results of our experiments. And one reason we haven't at scale implemented those types of systems yet, is that we are really evaluating them rigorously before we do that, so that they don't produce those misleading or biased or toxic outputs. So when it comes to teachers, there's also very little, so little you can do when it comes to doing that. The most important thing you can do is AI literacy. So educate your students about the how these models work, give them that sort of intuitive understanding, help them understand how to best ask questions of the model, and what to do if they feel the model provides responses which are impolite or that sort of make them feel uncomfortable.